Now I'm going to switch into the typical current or typical circuit notation. So switching from the battery to this shows me the battery. I'm going to add a switch in, some wires. I'm going to include the light bulb. Close the switch, and the current will start flowing. Notice that the electrons come out of the small end of the battery, but if I were to be modeling it in terms of the positive current, it comes out of the positive end of the battery. Resetting this, I'm going to build a more typical circuit. I'm going to now use a resistor. I'm going to get rid of the switch because I don't need to turn this thing on and off. And when I add the resistor element, which is shown here by this squiggly line, if I click values, it'll show me what the values of these are. This is using a 9-volt battery and has a 10 ohm resistor. That horseshoe thing is the Greek letter omega. Watch what happens if I change the resistance of this element. I'm going to decrease the resistance a little bit. Do you see anything change with the flow of electrons? What about if I increase the resistance quite a bit? Do you see how the electrons have now slowed down? Pretty sure slown isn't a word. When we have a higher resistance, the electrons flow more slowly. Another way I can increase the resistance back up, increase the current back up or the rate of electron flow, is if I increase the voltage. Now we're pushing harder on those electrons and we can increase the current again. This is going to lead us to our first law, which is known as Ohm's law.